All right, the second of our parabola problems, they kind of increase in difficulty as we go, but the process is exactly the same. There we can identify our y-intercept at -2, so it has coordinates 0, comma, -2. Gross, pardon me. Let's complete the square to find the vertex. So to complete the square, y equals x something squared. I'll still have that -2. I'll need to adjust by subtracting something. But what goes next to that x? Well, it's always half of that number right there. So half of that would be, quite literally, half of that. And I'm going to write it as half of that, 3 halves. You can do 1.5, but then you need to figure out how to square 1.5. And that's not so easy, but squaring 3 halves is super easy. And why am I saying squaring 3 halves? Because remember, this now represents a different value, and so we have to adjust that. We have to subtract 3 halves squared. So I will subtract my 3 halves squared. And it really is ideal to do it as fractions. I'll show you why right now. 3 halves squared, all you have to do is square the top and square the bottom. So if you square 3 halves, you get 9. If you square 2, you get 4. So we're going to be subtracting 9/4 from 2. So let's write 2 with the denominator of 4 as well. Well, that's going to be 8/4. Right? Multiply 2 by 4, you get 8. So 8/4 is the same as 2. So now we can simplify. Y equals x plus 3 halves squared. -8/4 minus 9/4. So what is -8 minus 9? Well, what is 8 plus 9? 8 plus 9 is 17. So this is going to be -17/4. If you like decimals, y equals x plus 1.5 squared minus, what is that, 4.25. So we have identified our vertex. Our vertex will be at the coordinates -3 halves, comma, -17/4. Or again, if you like decimals, -1.5, comma, -4.25. I think it's good to be comfortable with both. All right, what else do we know from this? We know that the axis of symmetry will occur at that same x value. So the axis will occur at x equals -1.5. And let's go ahead and set this equal to 0 and solve it. Now, I'm going to choose to set this equation equal to 0 because, again, it's gross with decimals and it's fine with fractions. So 0 equals x plus 3 halves squared minus 17/4. Let's add 17/4 to both sides. So 17/4 equals x plus 3 halves squared. Well, how do we get x? We need to square root that. So the square root of that fraction, 17/4, equals x plus 3 halves. What did we forget? Plus or minus. Have to have that plus or minus to get our two solutions. All right, where do we go from here? We're going to subtract 3 halves. So I'm going to write that as -3 halves plus or minus the square root of 17/4 equals x. And that still probably looks super gross to you, but it's actually not, I promise you, because this is the same as saying -3 halves plus or minus. You can think of it as distributing that square root to the numerator and the denominator in the same way we squared the numerator and the denominator earlier. So square root of 17 I cannot simplify, but square root of 4 I know is 2. So look, we have a common denominator of 2 and 2. So this is going to be -3 plus or minus the square root of 17. All of that over 2 will give us our two solutions, and there's our simplified radical. All right, decimal approximation of that. So I would open a parentheses. I would say -3 plus the square root of 17. Close your parentheses for the numerator. Close it 2 for the square root if you're on an older calculator, and then divide that by 2. And we get one x-intercept at 0.56. We'll round that to 2, comma 0. And then the other one, do the same thing, except -3 minus root 17 over 2. And we get -3.562. Again, it's the same decimal bit there. So those are our two x-intercepts. And we can go ahead and sketch a graph now. We have all the information we need. So again, get an idea of where you are. Our axis of symmetry is at negative 1.5, so we're going to be kind of favoring the left side. Vertex is at negative 4.5, so maybe something like that will work for us. So let's go 1, 1, 2, 3, 4 right there. Axis of symmetry is at negative 1.5, so we can dash that in. Looking something like that. Got a little wonky at the end there, but we're trying to make a perfectly straight line there. What else do we know? Let's go 1, 2, 3, 4, 5, and that should be enough because our vertex is at negative 1.5, negative 4.25. So if it's negative 4.25, we're right about there. We can label that negative 1.5, comma, negative 4.25. And what other points do we know? We know that the y-intercept is at 0, negative 2. So I can put that right there. So notice we're looking kind of steep there, but that's just because of our scale. And what other point do I get? If that's 0, comma, negative 2, think about it. How far away am I from that axis of symmetry? Well, I'm 1.5 to the right, so if I go 1.5 to the left, I'm going to have that same y value. So I should have that point right there at negative 3, comma, negative 2, like that. And then we found our x-intercepts. We're approximately 0.5, so I can put that in right there. And then approximately negative 3.5. So 1, 2, 3, right about there. And now we can sketch it in. Again, it's to the best of our ability, but try to make it look as good as you can. Right? We're not perfect, we're not machines, but I don't want to see things like that. I don't want to see things like that. Those are different graphs. If you show me that, I will be sad, and you will not get full credit there. So let's label these x-intercepts. That was 0.562, comma 0. And this one was negative 3.562, comma 0. And you could label them with the exact radicals if you wanted, but this is good enough for us right now.